Dear student, today we will be solving the IB Math AHL May 2025 paper 2 times on 1 question number 10. We will be getting the solutions for the first 9 questions from this paper and the solutions to the other questions from the other past papers in form of playlists on my channel NS Online Math Tutoring Classes. You will also be getting playlists where the solved past paper questions will be available based on their topics. I'm Nilanjana Sanyal. I'm an online IB Math AHL level tutor. My phone number and my website address are displayed at the bottom of the screen. So without any further delay, let us start to solve this question number 10. The maximum mark is 16. Rectangular playing cards are stacked in the shape of a pyramid with n rows where n is greater than or equal to 1. Some cards are placed horizontally and some cards are stacked at an angle of 60 degrees to the horizontal. So this is 60 degrees, okay? And some cards are placed horizontally. So this is one of the cards which is placed horizontally, okay? So the following diagrams represent pyramid stacks for n equal to 1, 2, and 3. So these are the 3 pyramid stacks. Let Tn represent the number of cards used to create a pyramid stack with n rows. Okay. So part A's question is write down T3. That means the number of cards that have been used to form this pyramid stack when n is equal to 3. So we have to basically add these. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. It is carrying just a single mark. Okay. So part A's question is T3 equal to 15. Okay. Part B, find T4. That means n is equal to 4. So you have to just, this will be this type of something. It will be of this shape. You will be having one more horizontal card over here, and then over here there are 4 pyramids on the bottommost row, and then there will be 3, then 2, and finally 1. That will be the structure of the pyramid stack when n is equal to 4. Okay. I have tried to draw this pyramid stack in this way. It is just a view from the front, you may consider. So, and we can just count the number of cards. So it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Okay. So therefore, T4 is equal to, it is carrying 2 marks. So I have drawn the diagram and I have just counted the number of cards. So T4 is equal to 26. Okay. So part C, show that Tn is equal to n times 3n plus 1 over 2. And it is carrying 3 marks. I will be showing this expression. I'll be getting this expression for Tn using 2 methods. Okay. So part C, method 1. Actually, there are several methods, but I'll be showing you 2 of them. One will be from the methods that you have learned in your IGCSE level. Okay. So method 1, this is not from the IGCSE level. So let us write the n value and the Tn value. So when n is equal to 1, the number of cards is 2. So T1 is 2. When n is equal to 2, The number of cards is 1, 2, 3, 4, 5, 6, 7. Okay. When n is equal to 3, we have written the T3 as 15. When n is equal to 4, T4 is 26. Okay. We can go on counting the different values of T they will be changing with the value of n. But this one is 2 is the first one. Let me keep it that way. This can be written as 2 plus 5. Okay. And 15, it can be written as 2 plus 5 plus 2 plus 5 is 7. 7 plus 8 will be giving us 15. This one is 2 plus 5 plus 8. 2 plus 5 is 7. 7 plus 8 is 15. 15 plus 11 will be giving us 26. Okay. So we are seeing when n is equal to 1, we are having a single number, that is 2. When n equal to 2, it is the summation of two numbers. When n equal to 3, summation of three numbers. When n equal to 4, but summation is of four numbers. Okay. So for Tn, obviously the summation will be containing n numbers. So therefore, Tn should be equal to 2 plus 5 plus 8 plus 11 plus dot dot dot. I am not finding the T5, T6, all those. I do not need them. But I know there will be n terms. Okay. In the Tn expression, it will be containing n terms added together. And this is nothing but an arithmetic series, where this is an arithmetic series where u1 is equal to 2 and common difference d is equal to 3. Okay. So therefore, Tn should be equal to, number of terms is n, so n over 2 and 2 times u1, so 2 times 2 plus n minus 1 times d is 3. So this is equal to n over 2, 4 plus 3n minus 3, which is equal to n over 2 and 3n minus 3n and plus 1. See, n over 2 and 3n plus 1. Let us write this in this format. So therefore, Tn is equal to n times 3n plus 1 over 2. This is the first method. Shown. Okay. In case you cannot think of this, that 7 can be written as 2 plus 5 and 15 can be written as 2 plus 5 plus 8. If you can not think of this, writing these numbers in this format, and as of course I've said that there are other methods also, I'm showing another method. Okay. So method 2. So they were 2 and then it was 7, 15 and 26. 2, 7, 15 and 26, and you have other numbers also. And I'm taking the difference. So 7 minus 2 is 5. 15 minus 7 is 8. 26 minus 15 is 11. Okay. Obviously, the difference is not the same. We do not have any common difference. So let us find the difference of these numbers. 8 minus 5 is 3 and 11 minus 8 is also 3. So over here at this level, we are having a constant difference. This is the second level difference. This is the first level difference. This is the second level difference. And we are seeing that the second level difference is a constant. When the second level difference is a constant, we can say this to be a quadratic sequence. When we have the second level difference as a constant, those sequences are termed as quadratic sequences. And any term for a quadratic sequence is expressed in this form. Tn is equal to an square plus bn plus c. Because it is a quadratic sequence, we have to have the square term. If the first difference would have been a constant, then it would have been a linear sequence. Then we would have had an plus b. Okay, but because this is a quadratic sequence, the Tn will be a quadratic expression, will be having a quadratic expression. And I'm writing that quadratic expression in the form of an square plus bn plus c, where we have to find the values of a, b, and c. Okay, so let me just rewrite these. It is 2 and 7 and 15 and 26. So 2, it is the first term. So n value is 1. So it will be a times 1 square, which is a, plus b times 1, which is b, plus c. So a plus b plus c is 2. What is 7? It is the second term. So n is equal to 2. So 2 squared is 4. So this is 4a plus 2b plus c. Okay. 15. This is the third term. So n will be equal to 3. 3 squared is 9. So it is 9a plus 3b plus c. And 26, it is the fourth term. 4 squared is 16. So this is 16a plus 4b plus c. Okay. And now we are getting the difference. So I'm writing the difference over here. 5 and then 8 and then 11. And I have got this number 5 by subtracting 7 minus 2. I'm subtracting 2 from 7. So similarly, I'll be getting the expression by subtracting this expression from this expression. So c minus c will be cancelling. Let me just show one of the subtractions. So 4a plus 2b plus c minus a plus b plus c. 4a minus a is 3a and 2b minus b is plus b and c minus c is 0. So 5 is having the expression 3a plus b. What about 8? 8 will be 9a minus 4a is 5a. 3b minus 2b is plus b and c minus c is 0. Coming to this one, it is 11. It is not h. So this is 11 and this should be 16a minus 9a. So it is 7a. 4b minus 3b is plus b. C minus c is 0. Okay. And now again 8 minus 5. It is 3. 11 minus 8 is also 3. So 5a plus b minus 3a plus b. So 5a minus 3a is 2a and b minus b is 0. Similarly, 7a minus 5a is 2a and b minus b is 0. So therefore, 2a is equal to 3 because we need to know the values of a, b and c. So therefore, we are getting this expression or equation 2a is equal to 3. Implies a is equal to 3 over 2. Okay. And 3a plus b is equal to 5. So let us take this equation. 3a plus b is equal to 5. So 3 times 3 over 2 plus b is equal to 5 implies b is equal to 5 minus 9 over 2. This is equal to 5 can be written as 10 over 2 minus 9 over 2. So therefore b is equal to half. Okay. Finally, we come to this a plus b plus c is equal to 2. So let me write it over here. A plus b plus c is equal to 2. A is 3 over 2. B is half. Plus c is equal to 2. Okay. So 3 over 2 plus half is 4 over 2. That means 2. 2 plus c is equal to 2. Therefore, c is equal to 0. Okay. So we get therefore Tn should be equal to, in place of a, I'll be writing 3 over 2 n square plus b is half, so plus half n plus c is 0. So this is equal to 3n square plus n over 2. Therefore, Tn is equal to, if you take out the common factor n, it will be 3n plus 1 over 2. Shown. I do not know how many students remember this method, but you have learned this method. You had learned this method in your IGCSE level. Okay. So this was the subpart C. There are 52 cards in a full pack of playing cards. Subpart D's question is, a complete pyramid stack is created using playing cards taken from 14 full packs. So the total number of cards should be 14 times 52. Okay. Find the maximum number of rows in this stack. Okay. Carrying 3 marks. So we have learned the total number of cards to be equal to Tn was equal to n times 3n plus 1 over 2. Okay. N is the number of rows, and this should be less than or equal to 14 times 52 because we are having 14 times 52 number of cards. So Tn cannot be more than this. Tn can be less than this or at most equal to this. Never, it will never exceed this number 14 times 52. Okay. So this is the inequality that we have to solve. So we have to use the calculator. First of all, let us find the product because this will be helping us in setting the window, adjusting the window settings. Okay. So let me get the product first. It is 728. Okay, fine. This is equal to 728. So now I'll be using the graphical method. So graphs, and it is in place of n, I'll be using x. So x times 3x plus 1 divided by 2. Enter. It is a parabola, no doubt, because it is a quadratic expression. And this will be a horizontal straight line, y equal to 728. So I have to first of all adjust the window settings. So let me go to number 4 window zooms and number 1 window settings, and xmin, xmax, they should also get changed. So let me take this as negative 100 and that to be positive 100. Okay, and y min, it is 728. So let me take 700, and y max, let me take it as 750. Okay, fine. And now I have to draw this horizontal line, y equal to 728. So 728. Enter. Fine. And this intersection will be giving us a negative value of x. But n should be a positive number. So I'll not be taking this intersection point. I'm interested in this one. So I have to go to analyze graph and then intersection. This one. Okay. It is 21.8642. So in value, n should be less than or equal to, this expression should be less than or equal to 728. Okay. So the intersection points in value, x value is 21.8642. N should be a positive integer. So the maximum value of n, which is less than 21.8642, is equal to 21. Okay. So n should be, therefore, n should be less than or equal to 21.8642. Therefore, n is equal to 21. This is the maximum number of rows. Okay. So part E. Complete pyramid stack is created using playing cards taken from full packs with no cards left over. Find the minimum number of rows in this stack. We do not know how many full packs they have taken, and each full pack contains 52 cards. Okay. So find the minimum number of rows in the stack, and no card is left over. All the cards have been used in creating the pyramid stack. So, okay. So let us take let K be you can take any other uh, letter or variable also. I'm taking K be the number of full stacks, not full stacks, full packs of cards. Okay. So therefore, n times 3, n plus 1 over 2 should be equal to k times 52. Okay. And k should obviously be a positive integer, and n should also be a positive integer. So n and k, they belong to the set of positive integers. And we have to find the minimum number of rows. That means the minimum value of n. So we have to use the calculator, and yes, you may say that you can use a slider, but what will you be taking as the minimum value is, of course, it is a positive integer. The minimum value of k can be taken as 1. But what will you be taking as the maximum value? You have to create, if you create a slider, then you have to take the maximum value also. So that will be a little difficult to decide. You may take the maximum value of k as 20. You may try, and you may see for uh, what value of k are you having an integer value of n. You can try that way. You can draw these two separate graphs. This will be a parabola, this will be a straight line. So, and you can try that way, or else you can use the table. So for using the table, you have to have the relation in the form of y equal to, means this side will be having, we will be having only a single variable which will be the subject of the equation, and this side will be having some other variable. Okay, so in this case, let us use this method. I'll be using the table. So I can write implies k is equal to n times 3n plus 1 over 2 times 52. Okay, this is equal to 2 times 52 is 104. So this is n times 3n plus 1 over 104. Okay, and now we can graph this. Y values will be giving us the k values and x will be n. Okay, so graph, and this is x times 3x plus 1 divided by 104. Okay, and now we go to the table. Number 7 table and number 1 split screen table. Okay, and x values represent the n values, and this part, the function value, is representing the k value, and we need those values of k and n for which both are positive integers. So let us just scroll down. Okay, so you see the k value is 5, this is a positive integer, and n value is 13. Okay, so using GDC graph tables, k is equal to 5 and n is equal to 13. But you may ask me that the question says find the minimum number of rows. We have got just a single value. How are you saying that this is the minimum? I don't find any minimum or maximum over here. There is only a single value of n. Yes, this is the first value of n that we can take, we can consider as the solution. So that is why it is the minimum value, because if you just go on scrolling, I have checked, you do get other values also, but for those values, the n value will definitely be more than 13. So the minimum value of n is 13. You have to just go on scrolling if you are not satisfied. If you have this query in your mind, you see this k is 91, so you are having 91 packs of cards, and the corresponding number of rows is 56. So the minimum number of rows will be equal to 13. Okay, so this was the answer for the SAPAT E. This is the minimum number of rows. Okay, and the long edge means this one. Okay, of each playing card measures 88 millimeters as illustrated in the following diagram. Subpart F's question is find the minimum number of cars needed to create a complete pyramid stack with a vertical height of more than 2 meters. This is millimeter and this is in meters. So we have to convert either this to meters or this to millimeters. Let me convert this to millimeters. So 2 meters will be equal to 200 centimeters and 1 centimeter is equal to 10 millimeters. So 2000 millimeters. Okay. So the vertical height should be more than 2 meters or 2000 millimeters. The thickness of the cars may be ignored. This is carrying 5 marks. Okay. I have brought in this diagram again. So over here in the question, they had said that these cars, they are at an angle of 60 degrees to the horizontal. So this will be equal to 60 degrees. Okay. And this one is 88 millimeters. Or let me take this one. This is also the same. It is 88 millimeters. Okay. And what is the height? This is 90 degrees. So the height will be h over 88 should be equal to sine 60 degrees. Okay. So for n equal to 1, h is equal to, when n is equal to 1, h is equal to, vertical height is equal to 88 times sine 60 degrees or 88 times root 3 over 2 or 44 root 3. Okay. Obviously millimeters. Now this is for n equal to 1. What will be the height when n equal to 2? This will be the vertical height and this will be the angle 60 degrees. And this one is 88, this one is 88. So when n is equal to 2, h is equal to, or h over 88 times 2 equal to sine 60 degrees, implies h is equal to 88 times 2 times root 3 over 2, root 3 over 2, and I am always cancelling this 2 with this 88. Okay. So this is 44. I can write this as 44 times 2 times root 3 millimeters. Okay. Let us see the third one also. When n is equal to 3, again this will be the height. Okay. This is 90 degrees. This is 60 degrees. And this will be 88, 88, 88. So 88 times 3. So h over 88 times 3 is equal to sine 60 degrees. Implies h is equal to 88 times 3 times root 3 over 2, cancelling. So this is equal to 44 times 3 times root 3 millimeter. So we are seeing that 44 and root 3, these two are common. When n is equal to 1, this is 44 times 1 times root 3. When n equal to 2, it is times by 2. When n equal to 3, this is times by 3. So the question is minimum number of cars. So first of all, let us find the value of n. How many rows are there? Minimum number of rows. So therefore, when n is equal to n, there are n number of rows, h should be equal to, you can write h is the vertical height. Okay, so h will be equal to 44 times n times root 3 millimeter, and this should be greater than, more than 2000 millimeter. Okay, so we are getting the inequality as 44n root 3 or 44 root 3n is greater than 2000, and we have to get the value of n. It is the minimum number of cards, so we have to get the minimum value of n. Okay, again I'll be using the graphs. Okay, it is 44 times root 3. It will be a linear graph, obviously, and times x. Yes, and this is 2000. So we have to change the window settings. So windows and window settings, and okay, x min, let me take it as negative 100 and x max as positive 100, and this one we will be drawing the horizontal line as y equal to 2000. So let me take this y min as 1800 and y max as maybe 2200. Okay, fine. And now I have to draw the horizontal line. It is 2000. Okay, and we need the intersection points coordinates. So analyze graph and intersection, and this is the intersection point. Okay, so we need the n value which will be more than 26.2432. Okay, because values of x which are more than 26.2432, for that part, this graph, the pink colored graph, is above this horizontal green colored line. This pink line is above this horizontal green line. Okay, so n should be more than 26.2432. Using GDC graphs, n should be more than, again I am showing 26.2432. So therefore, minimum value of n is equal to 27. Okay, that is the number of rows. So therefore, total number of cards it is the minimum number of cards actually. Total number of cards needed is equal to 27 times 3n, means 3 times 27 plus 1 divided by 2. So this will be equal to 27 times 3 times 27 plus 1 over 2. 1107. Okay, So we have completed solving this question number 10. Thank you for staying with me till the end. Please like and share this video in case you have liked my explanation, and please do not forget to subscribe to my YouTube channel. Your liking, sharing and subscribing will be really helping me a lot. We meet again very soon in our next session. We'll be solving the question number 11 of the same paper. Till then, bye.